you can see that it helps to know what the charges are on the ions. And so I do want to help you kind of just notice from your periodic table, if you haven't noticed the pattern yet, what the common ion charges are for each group on the periodic table. Here we're talking about monatomic ions, and monatomic literally means one atom. So we're talking about ions that are made up of just one atom on the periodic table. So group 1 forms ions with a charge of +1. Group 2 forms ions with a charge of +2. Group 13 forms ions with a charge of +3. Group 14 forms ions with a charge of +4. Plus or minus, it can gain or lose electrons. Then when we get to nitrogen, nitrogen always gains electrons in the nitrogen family for a charge of -3. Oxygen family with a charge of -2. And the halogens always have a charge of -1. The noble gases already have a full valence shell, so they don't form ions at all. Okay. Next, we need to learn how to name our ionic compounds. So when you're naming ions, cations are just named after the element. So if you have lithium with a charge of +1, you just call it lithium. If you have calcium with a charge of +2, you just call it calcium. The anion, naming the negatively charged ion, is a little bit more complicated because you're going to change the name a little bit. You're going to change the end of the element name to IDE. So fluorine, if it has a charge of -1, is no longer called fluorine. We call it fluoride. We call it fluoride. Similarly, oxygen, when it's an ion with a charge of -2, we call it oxide. Not oxygen, we call it oxide. So that's just naming the ions. How do we put those names together to name a whole ionic compound? When you're naming binary ionic compounds, and binary just means 2. So here we're talking about ionic compounds that just have 2 types of atom in the compound. We just write the name of the cation and then the name of the anion. And remember that the anion is always going to end IDE. You're always going to write the cation first. So let's try it. Magnesium is the cation. And because it's the cation, we just say the name of the element. It's magnesium. But we don't say magnesium oxygen because with the anion, we have to change the ending to IDE. So it's magnesium oxide. For CaF2, we name the cation first, and then we change the ending of the anion to IDE. So this is calcium fluoride. For K3N, we name the cation first, potassium, and then we name the anion, but we change the ending to IDE, nitride. And lastly, here we have aluminum iodide. So naming binary ionic compounds is fairly straightforward. Notice it doesn't matter how many atoms of the element you have, you don't change the name. It's just potassium nitride. There's no indication that there are 3 potassiums in the formula. And that's because we'll see when we start writing the formulas that it's obvious because potassium always has the same charge. So you should be able to figure out the right formula. We don't need to tell you the number of atoms present. All right, now let's look at writing these formulas. When you write the formulas, the total positive and total negative charges must be equal to each other because we want the overall charge of the ionic compound to be 0. The total charge is 0. It's also important to know that you do not show charges in the final formula. No charges. So, how do we do this? Step one is to think about what are these ions present in magnesium bromide. Now remember, we've changed the ending of bromide here, so don't go looking on the periodic table for bromide. You won't find it. You need to look for bromine on the periodic table. Once you find magnesium and bromine on the periodic table, you'll see that magnesium always forms ions with a charge of +2, and bromine always forms ions with a charge of -1. So we know the charges of the compounds. The question is, how do I put these together so that total there is a charge of 0, no charge overall? Because if I've got one of these and one of these, I have a total charge. +2 and -1 add up to +1. And I don't want that. I want a total charge of 0. So what I do is I look at what I don't have enough of. I have too many positives, not enough negatives. So I'm going to give myself another negative ion here. And now this matches up. I have +2 plus -1 plus -1. That equals 0. So this is the formula I want. 1 magnesium, 2 bromines, or 2 bromides. And that is, in fact, my formula, MgBr2. MgBr2, to show that I've got 1 magnesium and 2 bromides. Notice how I use that bottom right-hand corner to show me how many atoms of a particular element I have in the formula. Let's look at another example, aluminum oxide. Here, when I look up the ion charges, I have aluminum with a charge of +3, oxygen with a charge of -2. So now, when I look at those ion charges, I've got more positives than negatives, so I need another negative here. Now I have -4, and I don't have enough positives, so I'll give myself another positive here. Now I've got +6 and -4. So I need more negatives. If I give myself another oxygen, that's 2, 4, 6. I now have a total charge of +6, and so my positive charges and negative charges balance out. Notice I have 1, 2 aluminums and 1, 2, 3 oxygens, so I write my formula Al2O3. Last example, lithium phosphide. Lithium has a charge of +1, phosphide has a charge of -3. So in order to get up to +3 to balance out the -3, I need to have some more lithiums here. I need 3 total lithiums. So my final formula is Li3P. With these examples, if it helps you to write out all of the ions that you're including in the formula, absolutely do it that way. Really what I'm doing here is I'm trying to find the charge that is the least common multiple of the 2 ions. So if I have a charge of 2 and a charge of -1, the least common multiple of 2 and 1 is 2. So I'm trying to get a total positive charge of +2 and a total negative charge of -2. Here I wanted a total positive charge of +3 and a total negative charge of -3. This was really the trickiest one because 3 and 2, their least common multiple is 6. So here I was looking to get my total positive charge up to +6 and my total negative charge up to -6. I hope this helped.